Hi, welcome to Theme 14. This is the final theme of the GCSE course, and it's one that tries to bring together a lot of the learning that we've been doing up until this point. We're going to do this by interpreting geological maps. And for that, we need to draw on and revise a lot of what we've been learning so far. Okay, for this unit, you're going to need your light pink booklet. Okay then, let's go. Now I've called this unit the geologist puzzle box from a quote from a Swiss geologist from the 19th century called Louis Agassiz. I liked it because it really does describe what we do in Theme 14. We really are solving 3 and 4 dimensional puzzles about how rocks relate to each other, how they fit together into a geological story. This image we're looking at here is a geological map of a volcanic island. It's called Miyake-jima off the coast of Japan. The different colours on this map shows different rock types and different ages of the same rock type. Piecing this together, though, is what we learn for geological maps. But before we get there, I think it's really important for us to do some revision. It's been quite a while since we've looked at different rock types and how we can recognise those. And we need to be able to do that if we're going to be able to interpret geological maps. As ever, as we start a new topic, our first job is to have a go at what's in a word. These are the words for this particular topic. Now, unusually, with this topic, because it's retrospective, because we're looking back on what we've done before, these words are actually relatively familiar to us, or at least should be. An awful lot of them, for example, come from Theme 13. So, press pause now and have a go at that. Okay then, now you've had a go at what's in a word, let's have a look at some of these different rock types that we need to look at. On pages 2 and 3 and 4, you'll find diagrams taken from past GCSE assessments of different types of rock. I've selected 4 different types for each rock group. And for this first lesson, we're going to look at igneous and sedimentary rocks. So we'll find these on pages 2 and 3 of your Theme 14 booklet. There's a whole series of different terms that we need to use. What I'd like you to do, firstly for the igneous rocks on page 2, is to annotate your or these diagrams with the appropriate terms. These are the words we use for igneous rocks. Let's start by looking at texture. Texture, remember, is the size of any grains or crystals within a rock and how they relate to each other. So, for igneous rocks, we find textures that are random and interlocking. So random means there's no overall orientation of any crystals within that rock. The fact it's interlocking means that those crystals grow into each other and we don't see gaps between them. Crystalline means that the rock is actually made of crystals rather than that have grown rather than fragments that have been worn down. Now the next 3 terms, coarse grain, medium and fine grained, well, and glassy as well actually, relate to the size of crystals. Now for igneous rocks, coarse grained means crystals that are greater than 3 millimeters across. Medium grained means crystals that are between 1 and 3 millimeters across. Fine-grained is where we can see crystals, but those crystals are smaller than 1 millimeter. And finally, glassy is where we can't see any crystals at all. They're too fine-grained. So the rock looks like a lump of black glass. The last two words here refer to textures that are a result of rates of cooling. So porphyritic is where we get some very coarse crystals and some much finer crystals. So we get phenocrysts, the bigger crystals that have grown slowly, and then the smaller crystals, the ground mass that surrounds those, have cooled more quickly. So we get two stages of cooling. Equicrystalline means that all the crystals are about the same size, and that's the result of a steady rate of cooling. So those are the textural terms. For composition, we can describe igneous rocks as being mafic. This is where we have lots of iron and magnesium in the chemistry of the rock, and we see that because the rock will contain minerals like olivine and augite. But in particular, olivine is distinctive for mafic igneous rocks. The type of rocks we get that have a mafic composition are basalt, dolerite, and gabbro. Basalt is a fine-grained mafic rock. Dolerite is a medium-grained mafic rock, and gabbro is a coarse-grained mafic rock. Intermediate composition has a bit more silica, a bit less iron and magnesium, and the rock we need to recognise there is andesite. Andesite is a fine-grained intermediate rock. It can be a tricky one to identify, andesite. Finally, then, we have silicic igneous rocks. Silicic igneous rocks have lots of silica in them. Silicic igneous rocks tend to be lighter in colour, lower in density than mafic rocks, which are dark in colour and higher in density. And the reason for that is they contain a lot of quartz. So the key mineral in a silicic igneous rock is quartz. And the rock we need to know that is silicic is granite. Granite is a coarse-grained silicic rock. We do need to consider, as we've said, density. Silicic rocks tend to fairly low density, maybe 2.6, 2.7. Mafic rocks tends to be higher density, 2.9 or 3 maybe. And colour, which is a feature of the mineral composition. So those are our igneous terms. What I'd like you to do is to use those terms to annotate the diagrams of rocks on page 2. Have a go at that now. On page 3, we have our sedimentary rocks. Now, sedimentary rocks use different terms to describe them. So if we start by looking at the texture again. Now, there are different types of sedimentary rock. Clastic sedimentary, chemical sedimentary, and biological sedimentary. A biological sedimentary rock is one made of organic material. It's one that's made almost entirely of fossil material. A chemical sediment is one that's deposited by precipitation from solution. So something like a salt deposit, for example. And finally, a clastic sediment is one that's made up of fragments of pre-existing rock, solid lumps of rock. We can see that there are sedimentary rocks that are fragmental or clastic in nature, where you have these broken fragments. And these can be of different sizes. So the terms boulder, cobble, pebble, sand, silt, and clay all relate to different sizes of rock fragments that we find in sediments. Now, if you look back at theme 4, you'll see we have a thing called the Wentworth scale that defines these. A boulder is a fragment that's more than 256 millimeters across. A cobble is between 64 and 256 millimeters across. Pebble is between 4 and 64 millimeters across. Sand is between 2 millimeters and 1/16th of a millimeter. Silt is between 1/16th and 1/256th of a millimeter across. And a grain of clay is less than 1/256th of a millimeter. It's absolutely tiny. We can also use terms to describe these clasts. We could describe them as being well-rounded, if all the corners have been knocked off, or rounded, which would be, will have most of the corners knocked off. If they haven't had corners knocked off very much, then they're angular, or if they're really sharp edges, it will be a very angular deposit. We can also refer to the range of sizes within a sedimentary rock. So we can describe rocks as being well sorted if all the grains within the rock, if all the fragments are the same size. It's poorly sorted if there's a wide range of grain sizes within a rock. Somewhere in between is going to be moderately sorted. And finally, for texture, we can also talk about pore space. Pore space is the gap between the clasts. So when we look at composition then, we need to look at the composition of the clasts, the fragments of rock, and also the mineral that sticks it all together, the cement. We can also look for any fossils that are in sedimentary rocks. Remember, fossils are only found in sediments. They're more likely to be made of hard, resistant minerals, like quartz, for example. Quartz is very common in the sedimentary rocks because it's hard and resistant. The type of rocks we look at then, clastic rocks, we've got breccia or conglomerate. These are where we've got pebbles, cobbles or boulders in the sediment. Breccia is if those clasts are angular. Conglomerate is a word we use if those clasts are rounded. Sandstone is where we have clasts within a sediment that are sand size, so between 2 and 1/16th of a millimeter. There are different types of sandstone. We can have arkose, which has a lot of feldspar in it. Red sandstone, where we've got a coating of hematite on the grains, usually in desert deposits. Or we can have shales. Shales are mudstones, where we've got very fine fragments. Chemical sediments. A lot of limestones are chemical. And also evaporite deposits like gypsum or halite deposits, salt deposits from salt lakes will be chemical sediments. And we also have biological sediments as well. Coal, made of fossil trees. Chalk, made of microfossils with a calcite shell called coccoliths. Or you can get limestones as well that are almost entirely made of fossil shell material. So those are the terms we can use for sedimentary rocks. What I'd like you to do is I'd like you to label up the diagrams on page 3 of your booklet using these terms. And can we identify what each of those rocks are? Okay. We'll leave it there for now. So make sure we annotate pages 2 and 3 in as much detail as we can. It's really important to try and use accurate terminology when we're describing the different types of rocks. We use different words to describe the different types of rocks because they form in different ways. So, as we see the sunset over Miyake-jima, have a go at that to get us started with theme 14. Clearly, we need to still talk about metamorphic rocks and fossils, but that's for another lesson. I'll see you then.